whenever a chemical bond has to happen, there is a formation of a bond, and at sometimes even the breaking of bonds. So the energy that is found in a bond is what we refer to as the bond energy. And so if you are breaking a bond, say you have got a bond like this, when you are breaking this bond, the energy associated with the breaking of a bond, if you want to break that bond, you always need to take in energy. Okay, so energy has to be taken in to break a bond, and so the energy is positive. Now forming a bond, when you are forming a bond formation always releases energy. Okay, releases energy, and you are going to see that in bond formation the energy is going to be negative. That is because when you have got an element, just single elements the way they are, when these two elements come together, the reason as to why they are coming together is to lower their energy, and so some energy has to be lost. And so as you can see, the individual elements are higher in energy, but when they come together the energy is lower. Now if you want to break these into individual elements, notice that the energy is higher. So you need to put in energy, in other words. So this is very much important to understand when talking about bond energy. Now say you want to calculate the enthalpy of formation. Okay, calculate the enthalpy of formation of 1 mole of, let's give one example. When hydrogen gas reacts with let's say chlorine gas to produce hydrogen chloride, HCl. So this is hydrogen chloride. Now to balance this, I'm supposed to put a 2 here, but notice that we are interested in 1 mole of product. Okay, we want to form 1 mole of HCl because we're talking of formation. And so to balance it, instead of putting a 2 there, we're going to put halves here, and so that is a balanced reaction. Okay, now at this point we can just rewrite this and say half. The bond between hydrogen is a single bond like this. A bond between chlorine is also a single bond like that. Now that is going to produce hydrogen chloride. The bond is HCl like that. Now the bond energy for H and H, okay, the bond energy between two hydrogen atoms, these values are going to be given in a table. The bond energy here is the 432 kilojoules per mole. The bond energy between chlorine and another chlorine is 239 kilojoules per mole. The bond energy between hydrogen and chlorine is 429 kilojoules per mole. And so we're just going to substitute those values. So between H and H, we are going to substitute 432, and then plus half. Cl, we are going to replace 238, and that is producing HCl, that will be 427. Now if we work out on the reactants, the value we are supposed to find there, okay, let me just do the calculation. 432 divided by 2, that is going to give us okay, so this is 216, and then 230 also divided by 2, that is 1115, and this is producing 427. Now 216 plus 115, that is 331, and that is producing 427. Now here we are forming this compound. And so energy is going to be, okay, the formation of a compound always releases energy, and so this energy is going to be released, is going to be negative. Now bond breaking, we have to take in energy, because see, we were breaking these bonds before we can use them to form the other bond. And so bond breaking, the energy is always positive. And so the enthalpy for this reaction is always energy of the reactants, and then you remove energy of the products. Why are we removing? Because the energy of the reactant is positive. The energy of the products is always negative. And so 331 minus 427, that is going to give us negative 96. That will be kilojoules per mole. So this is the enthalpy of formation of 1 mole of hydrogen chloride. So basically that is how you can be able to form 1 mole of hydrogen chloride. Alright, now let's look at another reaction. We want to estimate the enthalpy of combustion, let's say, of 1 mole of a compound. So really anything about enthalpy when you've been given bond energy, just to understand the reactants and also the products. So we are talking of enthalpy of combustion. So the reaction we've been given is that being burnt in oxygen producing carbon dioxide and water. Now this is a common process. Whenever an organic compound burns in oxygen, carbon dioxide and water is released. And the compound that we have here is methane. So we've been given the bond energies. The bond energy between carbon and hydrogen is 413. The bond energy between two oxygen molecules is 495. Then the bond energy between carbon and oxygen, that is 745. These are all in kilojoules per mole. And this is 467. So now, having seen this, now from the reaction which we have, we need to break and see how these atoms are arranged in a molecule. So for methane, we have got carbon, hydrogen bonded this side, another hydrogen, hydrogen, and also hydrogen. Okay. And then we have got oxygen double bonded to another oxygen, and that will produce carbon dioxide. We have got carbon, one oxygen this side, and then one oxygen the other side. And that reacts with water, where we have got hydrogen here, oxygen, and then another hydrogen. Now consider just for the first one here. So there's a bond here, carbon to hydrogen. There's a bond here, carbon to hydrogen. There's a bond, carbon to hydrogen. There's a bond, carbon to hydrogen. So there are the 4 of them. So I've got 4 carbon to hydrogen bonds. And then we only have one bond between oxygen and another oxygen. And that produces, now we can see a bond between carbon and oxygen, 1, carbon and oxygen, 2. So we have got 2 bonds between carbon and oxygen. And then we have got a bond here and a bond here between oxygen and hydrogen. And so I've got 2 bonds between oxygen and also hydrogen. And so I'm just going to go on and substitute on those values. Now to find the enthalpy, and let's just substitute first. For the carbon to hydrogen bond is 413 joules, and then the bond between oxygen and oxygen is 495, and that produces the bond between carbon and oxygen is 745. The bond between, okay, this is a 4 here. The bond between oxygen and hydrogen is 467. Now let's punch our values on the calculator. So we are multiplying 4 by 413. and then we are adding now 495. So the value there is 2147. Over the other side, 2 multiplied by 745, and then now we add 2 multiplied by 467, so that is 24. Now the enthalpy, we know that this is bond formation, this is bond breaking. Always the bond breaking is positive, bond formation is negative, energy is released. So enthalpy is always energy of the reactants minus energy of the products in this case. So the reactants is 2147, the products is 2427. So 2147 minus 2427. So the answer that we're supposed to find there is negative 277. Just a moment. Let me see, this reaction is balanced. Okay, the reaction is not even balanced, so we were supposed to balance this reaction. So we left out a 2 at this point because we need to use balanced chemical reactions. If we put a 2 there, we should have put a 2 here to have a balanced reaction, and so we are supposed to have a 2 here, okay, at that point, even a 2 there, because we have got 2 in front, as you can see at that point, and then there is a 2 in front here. Now this bond oxygen and hydrogen 1, oxygen and hydrogen 2, now 2, and then we have got 2 of them, so that makes it now 4. Okay, so it was supposed to be a 4 at that point. So then that changes even these values because we didn't use what was balanced. So that is going to be 4 multiplied by 413, and then 2 multiplied by 495. So we have got 2642 on the reactants, and then on the products 2 multiplied by 745, and then plus 4 multiplied by 467. So that is 3358. Remember, this is supposed to be negative because it is bond formation, and so the enthalpy will be equal to the energy of the reactants minus the energy of the products, and that is the reactants we've got 2642, and then the products we've got 3358. So 2642. Okay, so that is supposed to give us negative 716 kilojoules per mole. So basically that is how we find the enthalpy of formation, combustion, and all these other enthalpies when you've been given the bond energies. Alright, thank you so much for watching. Stay blessed.